On the physics course, we also study light-dependent resistors. These are sometimes called photoresistors or cadmium sulfide cells. They are electronic components whose resistance changes depending on the brightness of its surroundings. They can be used to control the shutter speed in cameras and also in the control circuitry of oil burners. They can be used in street lighting to automatically turn on the lights at dusk and turn them off in the morning. I'm just going to show you what a light-dependent resistor actually looks like. So where my pointer is pointing, that little cell, where you can see like a little wave on it, that's a light-dependent resistor. So they're quite small. So the equipment we're going to use today is the little light-dependent resistor itself, and I've connected that via a set of leads to a multimeter, and the multimeter is being used to measure the resistance of the light-dependent resistor. And I'm also going to use different light sources just to vary the amount of light. We measure resistance in a unit called ohms, and I have my multimeter set on 1000 range. So at the moment it's about 10 p.m. at night. I just have a normal light bulb in the background lighting the room, and we can see that the LDR has a resistance of about 6.9 or so ohms. You saw when I moved the camera a little bit, I affected the amount of light falling on the LDR and its resistance changed. So at the moment it's about 6.8 times 1000 ohms, which is 6800 ohms. If I now turn on a bright lamp that's pretty close to the actual LDR, we should be able to see that the resistance has fallen to 0.4 times 1000 ohms, which is about 400 ohms. If I turn off the lamp, we'll see the resistance climbing back up, and again, depending on where I position the video camera, I'm going to affect the amount of light falling on the LDR. If I now come along and use my finger to cover and block out all the light from the LDR, we're now going to see that the resistance rises quite sharply. I'm just going to do a quick demonstration of Faraday's experiment. These are typical of the experiments that are on the Leaving Cert course, and they're not at all difficult. Okay, the equipment being used is a moving coil galvanometer, which is used to detect current, and I've got a coil of insulated wire which I've connected to the actual galvanometer, one onto the positive side and one onto the negative side. And I've also got 3 different magnets of different strengths. Okay, and a galvanometer is just an instrument that is very good at detecting small amounts of currents. As you can see on the galvanometer, there's no current flowing in the circuit at the moment. The needle is pointing at 0. You'll also notice that I've got a scale both to the right and to the left, and this is when the current flows in different directions, so we can tell. So what I'm going to do now is actually move a magnet inside my coil of wire and watch to see if I get a deflection. A deflection means that the needle will move either to the left or the right, and that would tell us then that a current is actually flowing in the circuit. I'm now going to move a magnet through the coil, and what we should see is a deflection or a movement on the actual galvanometer. So we'll try this magnet first. If I try a weaker magnet, I get a much smaller deflection. And if I try a stronger magnet, if I leave the magnet inside inside the coil, the galvanometer shows no deflection. So this tells us that only when there is movement between the magnet and the coil of wire is a current actually induced.